The aims of this guidance are firstly to bring greater coherence to the national curriculum by exposing core concepts and demonstrating their progression from year 1 to year 6, and secondly to summarise the most important knowledge and understanding within each year group and important connections between them. This video guide summarises the knowledge and understanding that year 3 pupils need to achieve by the end of the year in order to be ready to progress to year 4. There are accompanying materials which provide teaching guidance for each ready to progress criterion and example assessment questions. We recommend that year 3 teachers should read the guidance for both year 2 and year 3 so that they understand the starting points for year 3 pupils. In year 3, pupils need to know that 10 tens are equivalent to 100. And they should use this fact to work out how many tens there are in other 3-digit multiples of 10. 10 tens are 100 and 8 tens are 80, so 18 tens are equivalent to 180. Pupils also need to understand the scaling model of place value and know that 100 is 10 times the size of 10 and that 10 is 1/10 the size of 100. It's important that pupils have a sense of a movement through the place value units as a scaling of a unit rather than just grouping and exchange, as it will prepare pupils to multiply and divide by 10 and 100, and particularly as they move into decimals in year 5. So pupils will leave year 3 understanding these two different ways in which the unit of 100 relates to the unit of 10, the grouping and exchange model and the scaling model. Once pupils have understood 3-digit multiples of 10, pupils need to expand their understanding to cover all 3-digit numbers. They should be able to decompose 3-digit numbers using standard partitioning like this, and also use non-standard partitioning to decompose 3-digit numbers in different ways. And this supports mental calculation, for example, subtracting 2 meters from 342 centimeters. As well as understanding the quantity associated with numbers, pupils need to understand the position of 3-digit numbers in the linear number system. They should be able to place numbers on partially labelled number lines and also make reasonable estimations about the position of numbers on unmarked number lines. Teach pupils to mark midpoints to support them with this. For example, the midpoint of 0 and 1000 is 500, and 342, for example, sits roughly here relative to 0 and 500. Positioning numbers in the number system prepares pupils for working with scales on measuring instruments or charts and helps pupils compare numbers and make estimations. Pupils should have sufficient understanding of the number system to identify the previous and next multiple of 100 and the previous and next multiple of 10. And they should be able to do this without a number line. So the previous multiple of 100 is 300 and the next multiple of 100 is 400. The previous multiple of 10 is 340 and the next multiple of 10 is 350. And this will prepare pupils for learning to round numbers in year 4. So pupils will leave year 3 understanding these two models of 3-digit numbers: number as enumeration, which is the cardinality of a number, and number as measure, which is its place in the linear number system. Pupils need to be able to decompose the unit 100 into 2, 4, 5 and 10 parts. So 2 parts, 4 parts, 5 parts and 10 parts. And this supports future fractions and measures work. And starting to link, for example, 4 parts and 25 prepares children for understanding why 1/4 is equivalent to 0.25 when they meet decimals in year 5. This decomposition of 100 relates to number as measure because it allows pupils to use common graphing units. They should be able to complete and read scales marked in 2 parts, 4 parts, 5 parts and 10 parts. And pupils should be able to read values such as these on partially marked scales. So the 2-part scale, 4 parts, 5 parts and 10 parts. In Year 2, pupils learn to add and subtract across 10, supported by tens frames and part-part whole jottings. In Year 3, pupils need to move beyond relying on models and jottings to solve these, and they need to become fluent in all of the addition facts shown here and in corresponding subtractions. During Year 3, pupils also need to start memorising their times tables up to 12 times 12 and be able to derive corresponding division facts. This guidance suggests starting with the 10 and 5 times table and then the 2, 4 and 8 times table, so connections can be made between related times tables. As we've seen in Year 3, children need to be able to work in units of 10 across the hundreds boundary. Pupils need to be able to apply this knowledge to number facts by working in units of 10. So pupils know that 8 adds 6 is equivalent to 14. So they can reason that 8 tens add 6 tens is equivalent to 14 tens or 140. And the same idea of applying known facts to units of 10 applies to multiplication. So 3 times 5 is equal to 15. So 3 times 5 tens is equal to 15 tens or 150. Pupils also need to find complements to 100 in Year 2. 62 plus 8 ones makes 70, and another 3 tens makes 100. This prepares pupils for finding change, for example, knowing that if I have a £10 note and spend £6.20, I will get £3.80 change and not £4.80. Pupils should also be taught the formal written method of column addition, working with addends with 2 or 3 digits and including regrouping. Deans can be used to model the methods so that children understand the significance of each digit in the recording of the formal algorithms. Pupils should also be taught the formal written method of column subtraction, and again, Deans can be used to model this. Pupils have been taught about the additive relationship throughout Year 1 and 2, and in Year 3, pupils need to develop flexibility in working with this relationship. They should be able to write and understand the 8 equations that can represent an additive relationship and know how each part of these equations relates to models showing the whole and 2 parts. Pupils should use this understanding of the additive relationship to solve calculations involving finding a missing addend, a missing subtrahend, or a missing minuend, and understand what calculation they must use to find the missing number. So the missing addend, the missing subtrahend, and the missing minuend. In multiplication and division, pupils must be taught that multiplication is commutative. 4 groups of 5 and 5 groups of 4, for example, give the same product, 20. Knowing that 5 groups of 4 gives the same total as 4 groups of 5 means that children do not need to learn 5 times 4 and 4 times 5 as separate times table facts. Pupils should be taught that the division facts they're learning can be applied to 2 different division structures: quotative division and partitive division. In quotative division, 20 is divided into groups of 5 and there are 4 groups. In partitive division, 20 is distributed equally between 5, with 4 in each part. In Year 3, pupils must be given a solid grounding in fractions. They must learn to use fraction notation to represent a part of a whole that's divided into equal parts. So here the whole is divided into 6 equal parts and one of those parts is shaded. 1/6 of the whole is shaded. Pupils should learn that a non-unit fraction is made up of a quantity of unit fractions. For example, 5/6 is made up of 5/1/6. And they should practice using unitizing language to emphasize this, interchanging the language of 5/6 and 5/1/6. Pupils should also be taught to find a unit fraction of a small quantity, and they should link this to partitive division, the equal distribution of a quantity into a defined number of parts. Pupils know that 15 divided by 5 is 3, so therefore 1/5 of 15 is 3. Pupils should only find fractions of quantities which correspond to a known division fact, so that the focus is on the concept and not on the calculation. Pupils must also understand that fractions are numbers, and they should become familiar with seeing number lines labelled in fractions and practice counting in different unit fractions. So as well as counting 1/5, 2/5, 3/5, 4/5, and so on, pupils should also practice dual counting: 1/1/5, 2/1/5, 3/1/5, 4/1/5, 5/1/5, or 1, to emphasise that inside non-unit fractions there are repeated unit fractions, and this will prepare pupils for addition and subtraction of fractions. Pupils must be able to identify numbers on partially labelled number lines. So here the 0 to 1 interval has been divided into 4 equal parts, and so each of these parts is 1/4, and the number indicated is 3/4. This will support pupils with ordering fractions and calculating with fractions and reading scales. So from all of this, pupils will understand that non-unit fractions are repeated additions of unit fractions. For example, inside 3/8 is 3/1/8. And the addition and subtraction of fractions with the same denominator then follows logically. So 3/1/8 plus 2/1/8 is equal to 5/1/8. And the same unitizing principle applies to subtraction of fractions. 5/1/8 minus 2/1/8 is 3/1/8. Pupils should also be able to add and subtract fractions presented as equations and go beyond needing images as a scaffold. In geometry in Year 3, pupils should be taught about angles as a measure of turn and as a property of shape. And pupils should be taught to recognise right angles presented in different orientations. Pupils must have opportunities to handle and manipulate shapes, and they should compose and decompose shapes to make other shapes. For example, joining two identical isosceles triangles like these to make a kite or to make a rhombus. Teaching pupils to see shapes within shapes prepares them to decompose shapes, for example, when finding the area of compound shapes. Pupils should be taught how to draw shapes. They must be taught how to mark vertices and how to position and hold a ruler to accurately join two marked points. Pupils should draw shapes on a variety of grids and papers to have plenty of opportunity to embed the precise drawing skills that they're going to need through Key Stage 2.